Welcome to the fastest way to learn data structures and algorithms, with this premium revision material. Today, we are mastering LeetCode 169, the Majority Element Challenge. This problem is a classic interview favorite, asked frequently at companies like Amazon, Google, Adobe, and Microsoft. Let us dive straight into the problem statement. Given an array of size n, your goal is to find the majority element. But what exactly defines a majority? In this challenge, it is the element that appears more than n divided by 2 times. You can always assume that a majority element exists in the input array. While you could solve this by sorting or using a hash map, those methods use extra time or space. Our mission today is to achieve the optimal solution: linear time and constant space. To understand how we can do this without extra memory, let us look at an analogy we call the last stand. Imagine a grand election where different candidates are competing. Every time 2 different candidates meet, they cancel each other out in a battle. Because the majority candidate has more than half the total votes, even if every other candidate teams up against them, the majority candidate will still be the last one standing. This is the heart of our algorithm: survival of the most frequent. Our strategy is the Boyer-Moore voting algorithm. It follows a simple but powerful golden rule. We maintain a candidate and a count. If our count is 0, we pick the current element as our new candidate. If we see the same element again, we increment the count, effectively gaining a supporter. If we see a different element, we decrement the count, representing a battle where both votes cancel out. The survivor at the end of the array is guaranteed to be our majority element. Now, let us walk through the dry run. This is where the logic truly comes to life. Look at our array on the screen: nums equals 2, 2, 1, 1, 1, 2, and 2. Notice the variable tracker box. It will keep track of our candidate and our count as we scan the array from left to right. Currently, candidate is none and count is 0. At index 0, the value is 2. Since our count is 0, we assign 2 as our candidate and set the count to 1. Look at the tracker: candidate is now 2 and count is 1. Moving to index 1, the value is also 2. This matches our current candidate. We increment the count to 2. Our candidate 2 is gaining strength. Now at index 2, we encounter a 1. This is different from our candidate 2. The 1 battles one of our 2s and they cancel out, so we decrement the count to 1. At index 3, we see another 1. Again, it is different from our candidate. They cancel out, and the count drops to 0. Look closely at the tracker. Our count is now 0, which means our previous candidate has no more supporters left. At index 4, the value is 1. Since the count is 0, index 4 becomes our new king. Candidate is now updated to 1, and count is set back to 1. Next, at index 5, we see a 2. This is different from our new candidate 1. They cancel out, and our count drops to 0 once more. The battlefield is empty again. Finally, at index 6, we encounter the value 2. Since the count is 0, we pick 2 as our new candidate and set the count to 1. We have reached the end of the array. Our final survivor in the tracker is 2. Because the majority element is guaranteed to exist, we can confidently say that 2 is our answer. Now that we have walked through the logic visually, let us see how these steps translate into our Python code. We start by initializing candidate to none and count to 0. Then, we iterate through each number in our array. If our count hits 0, we immediately assign the current number as our new candidate. Next, we check if the current number matches our candidate. If it does, we increment the count. If it does not, we decrement the count. Finally, after one single pass, we return the candidate. Let us look at the complexity. This algorithm is incredibly efficient. Since we only scan the array once, the time complexity is O of n, where n is the number of elements. And because we only store 2 variables, candidate and count, our space complexity is O of 1. No extra hash maps or sorting required. And that is the majority element challenge mastered. Save this video for your next interview revision, and follow for more deep dive DSA explainers. Send this to your coding partner to help them level up.